Hey, hello, welcome to the show. It is me, JP, newly clean shaven, even since that little thumbnail image was made yesterday. Thanks for stopping by. This is my show that we call JP's Product Pick of the Week. Did I mention that? It's Tuesday, so that's what that means. And thanks for jumping into our chats. By the way, I feel like I've been remiss and never made a little window for the YouTube chat. I always talk about it, but there it is. Look, there's Comet Mace and Dave Odessa. Hello, thanks for stopping in, and I'm sure some of our other regulars will be stopping by later. Our other main chat is this one right here in the Discord. Head on over to adafruit.it/Discord, and you can look for that live broadcast chat channel right there. We have Sam J. Ohio and Jim Hendrickson and C. Grover, Thin Man, DK. Howdy, thanks for stopping by. Thanks so much. So looks like we've got a, let me bring this out of here. Looks like we've got a show. We've got a pretty cool product pick that is one of the oldies but goodies from our archive. So I hesitate to call it a new product. This is a quite early number, early three-digit number for product ID. And in fact, if you want to go just get a jump start on it, look right there. It's ID 254, the 254th, roughly, project, or product, I should say, that Adafruit put out. Head on over there. You can also go to that QR code if that's how you like to get there. And this show is broadcast from inside the product page, so you can just jump in there, hit go, and you'll see it. Right, you'll be, I'm among all of the product stuff. This one is 50% off, and we had 100 of them stashed. We have 100 in stock. It says right there. Go check it out. It's half priced. There's no coupon code or anything like that. So if it's something you want, just throw it in your cart and get it. If you get it before the show or before the show ends or soon thereafter, you'll get it at that price. We don't do back orders or anything like that. So if they sell out, they sell out, but I don't think they will. So no promises, of course. Let's get with it. Now, typically at this point in the show, I will have Lady Ada introduce the product pick from a new product video, but this one's old enough that I don't think there was one. There may be one buried somewhere in our video archive, but I sure couldn't find it on YouTube. Most products have a new product video. This one did not. So I will skip that and cut straight to the chase. This right here is the product pick of the week this week. You can tell it's from Adafruit. Let me flip it around for you. This right here is the I should say this is the MicroSD card Breakout Board Plus. And I'll at this point jump into our little in-stock and price ticker there on my Fruit Jam. So this is a MicroSD card Breakout. You'll notice it's a little bigger than some of them. It has this big chip on here. What's going on? This one has a really nice voltage regulator. Unlike our other MicroSD card Breakouts, I believe this is the only one that can be used on 5-volt systems. So microSD cards themselves run at 3.3 volt and 3.3 volt logic. This has a really nice voltage regulator on it and a really nice level shifter on it. So we can take 5 volts and get 3 out where we need it. We can take 5-volt level logic on something like an older Arduino and convert it over to the level shifted over to the 3-volt logic that we need to safely use a microSD card. This one provides 150 milliamps of power to the card, which is great because power-hungry cards can ask for a lot. So this will give you all that you need and more. And this operates on SPI. So this is you're not gonna use this for SDIO. SDIO is a different thing, but this works with both the Adafruit SD card library and the more modern SD card IO library inside of CircuitPython, and we have libraries to use it with Arduino. So let's take a look at the product page for it. I'll jump over here. As you can see, $3.75, so that's a really nice price, and normally this one costs more than the simpler cards that only run on 3 volt, just because there's more parts on here with the regulator and the level shifter. And you can see we've got a reader slot on there, that is a really nice spring-loaded one. So I'll show you a demo with this running in a second. So you can click it in and click it out. No need to try to pinch your fingernails around it and pull it like on some slots. This is a nice click one. Just be careful you don't fire your SD card across the room. That can happen. This comes in a nice little bag, little Ziploc bag there, static safe one, and a little slice of header pins. So you can either mount these, you'll solder it like so and plug that into your breadboard or your Perma-Proto board or other circuit board, or you can mount this vertically if you want to plug socketed cables into it, if I can find it. So that's an alternate way to do it. And the MicroSD card Breakout board has 4 mounting holes on it, so you can attach that to a project if you have the holes drilled out, if you make a 3D printed case or laser cut case, that sort of thing. I believe these are M2.5 friendly holes on here. What else? This is a, as I said, let me go to a nice close-up picture here. As I said, this is for SPI, so you'll see these pins on the photo there that have arrows on them. So we have chip select, data in, data out, and clock. Those are the 4 pins that you'll use for SPI. And we have ground and either 3 volt or 5 volt, depending on what you have coming in from the board that's powering it. Also, you have the optional card detect. That's that pin up at the top that says CD. I like that. I'm going to use that. I'll show you that in the demo, where you can tell the code to look for a card when that gets clicked. So when you put the card in and click it, there's a little button, tiny little button in there that you can use to detect that a card has gone in and then execute a read. Let's see, any other facts about it? We have an activity LED on it that blinks red when accessing the card, either for a read or a write. And what I'll do is jump over to back over to the browser here. If you scroll down a bit, you'll see we have a link to the main Learn Guide, as well as a couple of Learn Guides that use this. So this MicroSD card Breakout board tutorial, head on over here. This will show you all of the facts about it and some notes about formatting cards, the wiring setup here for Arduino, and that's pretty much the same for CircuitPython, just match the pins. And then we have libraries for Arduino, how to install, and some examples. And same with CircuitPython here, how to install. And there's some nice examples for reading the card. Like I said, I recommend SD card I/O. So you can mount the file system on the card and read the files on it. Just remember, we now need a directory on the CircuitPy drive called SD. So as of, I think, CircuitPython 9 or 10, we needed to add a directory that's used to virtually mount that. So look for that. However, it does mean you can access the files from the desktop if you have this plugged into your computer. All right, let's see. Also in the Learn Guide, we have a download section here that'll give you datasheet for the microSD card reader, and then we have an EagleCAD PCB file and a fritzing object if you want to build diagrams, fritzing diagrams with this. So at this point, why don't we jump into a demo? I'm gonna go to overhead view here. So while I said one of the strengths of this one in particular is using it with 5 volt systems like an Arduino, I didn't do that just because I had this Clue board kind of with the dragon tail and a breadboard ready to go, and I thought this would make for a nice demo. So you could imagine using this on a 5 volt system if you like, but I'm going to use it here on this 3 volt system. So I have a Clue, Adafruit Clue board here plugged into my breadboard with the little edge connector dragon tail. And then you'll see here, I've got my MicroSD card Breakout board plus, and I have it going to 3 volt power in this case, ground, and then the 4 SPI pins, and I am using that chip or card detect, CD card detect pin. So you'll see right now the LED on here is lit, and then I think it's going to blink when I insert the card. So you can see it read the card there, and if you look on my screen here as well as my REPL, that's a little out of focus. Let me refocus that screen. On that screen, I know that's a little washed out. I can take down that exposure a tad too. There you go. So you can see in my REPL there, when I inserted that card, I read the contents of it and printed it out. And then I have a series of very small bitmap icons on here, and I'm just using the buttons on the clue to read those off of the card and display them. So you see each time I press a button on the clue, I advance or go back, and the little LED blinks as we access the SD card. So it's nice and fast. I believe in practical terms, SDIO, which is I think the 6-pin connection to SD cards, those might be about 50. Well, no, 2 to 4 times faster, I think. So definitely if you're streaming audio and things like that, you'd probably go for those SDIO capable cards and chips on your microcontroller. But for something like this, reading little files, logging data, reading text off of them, this is going to work perfectly fine. The data rates are very good. If you look over in my code here, you can see I am importing that SD card IO library, and I'm also importing storage. And then I'm setting up some pins. The card detect I'm setting up as digital pin 16 as a pull-up. And then I have SPI set up here on board SCK, MOSI, MISO, and chip select on D10. And then the SD card is this setup here using SPI and CS that we had already specified. Set up the file system and the storage mount as that SD directory. And then I have some code that just kind of loops through the file, reads the files using OS list directory, and then the path to SD, and reads the files out and spits them out for me. I'm just looking for BMP files, so that's what I print. And then I have a little function here called show image, which checks for a file on the disk and then displays that as a bitmap using display IO's on disk bitmap. Some little centering code as well as some text code to put that down at the bottom. And then the main loop, I'm just looking for button presses, like I said, button A or button B to go forward or backward. And then we're checking for a button press on those, and then showing or not showing an image. And I think in the main loop, you'll see here, if I go ahead and, I don't have any code to handle unplugging the SD card, so right now it thinks it's fine. If I try to advance, it's going to fail. But if I reset here, this actually gets stopped. We're not in the main loop. We're waiting for the SD card. You can see I print out a little thing there, waiting for SD card. So that's up here at the top. And then if I take my SD card and load that in, easier said than done in a live demo. There we go. Click, click. It reads that, and now it'll print out all of the BMP files that it finds on there. And that is the demo. So you can see here, it's a nice, simple setup there. 4 wires for SPI, ground, and power, and then the additional optional card detect. So let's see. Any questions in the chat? Let me know. I don't think there's a lot more to say about it. Did we miss anything? No, I don't think so. All right. Well, I think that's going to do it. So that, let me, I don't have a battery on this, so I'll keep this connected to USB. That right there is my product pick of the week this week. It is the MicroSD card Breakout Board Plus. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week. See you next time.